Welcome back, everyone, to Data Science for Everyone. Today we're going to be talking about importing data and data selection. And so let's get started. So, what we're covering is just how to import and grab data inside of pandas. Now, this all of this comes to this uh, pd dot read underscore, and if we were to hit the tab function after we type this out, we would get all of these types of file formats that we can import. The most common types are CSV, JSON, HTML. You can even grab stuff from your local clipboard, which is absolutely fantastic. Excel, open documents, again, but there's all kinds of stuff, okay? If it's a file format, we can open it. Now, if I run this down here and I do the pd.read underscore and hit, whoops, I didn't want to hit tab that quick. Let me pull this up just a little bit so we can see here. So you can see here all of these types here, okay? So it just depends on what you want to grab, who you're working with. So JSON is very common, for example, for when we're dealing with online API queries, that type of stuff. I use the read.html all the time because it's a great way to quickly kind of, it's not necessarily scraping a website, but if you know that it has some nice formatted HTML table, it will actually grab that table for you, and we'll go through an example of that maybe a little bit later. And then all these others are just very common data types, particularly Excel and CSV. So I'm going to be using the Heights CSV dataset. It's a very common dataset. I'm actually grabbing this from the R for Data Science book. And we're going to just use this curl function to import or download that data. And you can see that I've actually ran that. Just to show you, again, this is just a basic example. Again, this is just going to come through from trial and error when you guys are trying to import data and practice with data. So what we'll do, the first thing is importing a CSV. This is usually the kind of the standard practice here is pd.read CSV, or again, if you're using Excel or anything else, it's going to be using this Heights CSV. Now let me show you what the actual CSV file kind of looks like here. And the code that I'm using right now is actually some shell script or bash, so that I can actually look at this. So if you see here, this is what the CSV file itself, the pure text, looks like. And I can zoom in a little bit there. And so this first line here is the header row. Okay, you can see that it's relatively well formatted. Now, CSV stands for comma separated values. So we get a comma in between each of the values that we have here with a blank space at the end of a line so that it knows that it's going to a new line. Now, in other countries, for example, though, besides the US, you may have it as a tab separated value, a semicolon separated value. I've seen all kinds of very weird things, okay? So just be wary. I usually run this particular line of code to kind of see what's going on beforehand so that I'm not guessing. So you can change that with the sep feature in here. So if I type in sep is equal to, and then so for example, if it was a semicolon separated value, I could put in a semicolon in there. Or if it's, again, if I want to explicitly say that it's a comma separated value, that's it. But a comma is the default parameter setup. Now, the next thing we will always want to do is look at the head of the document. Now, this also assumes, for example, that there is a header. Okay, this is what a header is this here where we have their earnings, their height, their sex, their education background, their age, and their race. So just know that that is possible. Now, the next thing, so for example, if a lot of times, sometimes CSV files will come with no header whatsoever. And so that is possible. So then you would have this header is none. Now, if I run this just with our heights CSV, we actually get a little bit of an error, or not an error in here, but I mean, it is an error, but it'll just give us this numerical 0 to 5, and it'll count all the way up to however many columns that you have, but it gives us this piece right here. Notice it takes that header row and it assumes that it is now a row in and of itself, and that there is going to be a problem. Now you can, okay, there's some fantastic behavior in here. Besides this header.csv, we have this skip rows, or skip blank lines, skip a footer, okay, skip rows. And what that is that sometimes you will get an Excel file or a CSV file or something that has a ton of headspace. So maybe it's just a paragraph of a description of the data, and you will want to use this skip rows once you can kind of, if you do the head, for example, like we did here, and you see that there's a bunch of text here. You may be able to you may want to just count up the number of rows that you need to skip, and you can skip it. Now the next thing is also using a comment. Okay, so a lot of times people will use the hashtag symbol, okay, and say, like for example, this is a comment. All right. Well, if that is inside of a block inside of your CSV file, you can tell it to use the comment. So here, let me just type this here. Is comment is equal to, and so for example, you could give it a hashtag symbol, or maybe the comments are used with maybe they'll sometimes use like a pip, okay, or something else. But you can do that, and you can control that behavior yourself. I just want right now, I wouldn't expect anyone to even remember half of this stuff. I just want you guys to know that it exists, and that it is very useful when you start cleaning data and you're getting unknown data. Almost every time I wind up using this, particularly when it's messy data. Now let me move over to another tab that I have here, and you know what? I'm going to also talk about this has been just importing data, and I've been using it as a CSV. But what I can also do is let's talk about how we export data to different file formats. So a lot of times if you're importing data as a CSV file, you're going to be having trouble, and you're going to say, oh crap, my boss told me he wants this in an Excel format. So how am I going to go about writing this in Excel format? Well, we have our data set, okay, df, and then all we have to do is do this dot to underscore, and notice here, you can put it towards anything that you want, okay? So you can have it as, you can put it to your clipboard, you can put it to a CSV, you can put it to a dictionary. You know, let me just run it to a dictionary really quickly, so that you can, if I run this, notice here, it actually exported it to a dictionary. All right, and again, it's having here is some row here, and all of that information. And it looks very messy. Okay, you can even do the very common one would be, for example, to JSON. I want to do that so that you guys can see it. So again, here, this is a compressed JSON file. Okay, and you can tell it, so for everything, let's just call this, it's heights.json. Okay, and I can run it, and this will actually export it to here. So notice, now we have a heights.csv, that was our original file, and then I converted it to a JSON file. We can also go about turning this into, let's say, to an Excel file. Again, this is a very common format, and let's say heights.xlsx. And again, when I refresh here, now we have our Excel file as well, and these are all well formatted. Now there is an issue here, okay? So let me go about this in another way. So let's just call this df2 is equal to pd.read, and I'll just pick up the Excel one for now. And let's take a look at this. So before, let me show you guys what the original looked like. So df.head. So this was our original. Now if we look at df2.head and I run this, notice something. We have this unnamed 0. Okay, now this is all because when we did this write to, okay, this to Excel, and this happens also with the JSON, it assumes you want to keep your row index. Okay, it assumes you want to keep that row index, and so then it's going to give it to you, but it's not going to name it, it's not going to do any of that. Now, assuming you want to keep it, that's great, but in this instance, we did not want to keep that that index. So if we go about this and do df.toExcel, and then I'm going to call this heights with index.xlsx, and then so here, if you notice, if we look at the parameters in here, we can even put sheet names, how to do defaults, columns, headers, and now right here, there's one that says index. Okay, its default is set to true, so then we want to say index is false, and we run this, and then now let's check this, and I'm going to import this as df3 is pd.read and then Excel, and then we want heights with index.xlsx, and then so df3.head. And now notice, okay, in between this first example here, it has this index column in here that it kept. Here now it does not. So that is significantly cleaner. And I've seen this many times, and it's okay, it's not a big faux pas or anything else, but it is a little bit annoying. I've gotten many CSVs or text or files from colleagues, okay, and it has like unnamed 0, unnamed 2, unnamed 002, and what it is they just keep making copies of copies, and they don't clean up their data. Okay, and so having 4 or 5 of these eventually is going to be a little bit messy, and it's going to crowd up a relatively clean, pretty data set. So just make sure that we take time out to look at how we deal with exporting our data. And let me see about maybe we can do maybe one more example here, something that may be a little bit more fun. Okay, you know what? Let's go about importing data from the internet. Okay, so specifically, let's grab up some data from a website. So I'm going to minimize this a little bit, and I'm going to go to the FDIC failed bank list. So whenever I was, a lot of people know this, but there is a lot of failed banks. Okay, particularly this is the list from that have failed since October 2000. So I'm going to just grab this, and notice I'm grabbing the whole entirety of the web page, okay, the whole web address, and I'm going to go in and I'm going to take this in, and so I'm going to call this I'll make this as a temp. I'm going to call it temp data frame, and so we do pd.read HTML, and then we actually put in that web address. Okay, now what this is going to do, and let me get out of this and go back to the website. If you see here, there is this HTML text in here. Okay, this is just a nice table. We can even, and here in a second, we'll even grab something maybe from Wikipedia to show you guys how to grab data from those HTML sources. Whoops, let me move back over to this one. So if I run this, let me just show you just the whole thing. Now notice what happens, okay? It gave us this very weird looking format, okay? So what is this that it downloaded? Well, we can see that it actually has some of those names, right? It has that, it has the data that we were wanting. But if we take a look here and do type, type on this, it actually gives us back a list object, okay? And the reason that is that maybe when you have, if you're scraping data from a website, there may be 10 or 15 different tables on that website. Well, we need to be able to know which one that we want to grab. So I know just by looking at this temp data frame here, I can see that, well, actually, my guess is that it's probably just the first one here. So if I grab this and I index this as I would have listed 0, and I run it, notice, bam, this is actually scraped data from the FDIC website, and it was very, very quick for us to grab a hold of. All right, it's very clean, and we're able to grab a hold of it. Now, the thing that I would do is save this then is, let's call this banks. Okay, so we're actually grabbing and subsetting out that data, and now we have a banks. Well, let's just look at the head. Okay, and now let's also look and see and make sure. So here, for example, these were supposed to be numerical. Again, this is a date, but it's not going to be a date time object. So we're expecting string, probably an integer here, and then strings for everything else. So if we look at banks.info and run that, and we actually see that is the case. So everything is an object of that type and is an integer 64. Now, there is a little bit of an issue here, okay, is that there's only 563 rows here. So from the website, my guess is that it only grabbed what was visible to us here, okay? So it's, again, if you want to grab, for example, all of them, you would have to rerun this for all of them, and it would take you maybe a little bit of back and forth playing, because again here, if you look, just the first page is that 563 entries. You may want to be able to loop this or do anything else, but we also have here a download icon. So if I click the download icon, let's see what it actually gives. Notice it gives us this bank list.csv. Now, a couple questions on this though is, how could we potentially do this if we wanted to grab just this link? Now, I'm going to just copy the link. Oh, I don't want to copy that. I want to copy the link. Copy link address. Now, there are a couple ways to do this. It depends on what this is actually pointing to. If it's pointing to a raw text file, we can download it. But sometimes, and I don't know if this will actually work at this particular moment, but if we put in this and I run this, notice that it works. Okay, I grabbed it just the location of that data set. Okay, now again, notice something though, it is only those rows that were available to us. So again, this is something that you would always have to work on. There may be an issue with their website that only allows you to grab so many queries and whatnot. But this is just another way. You can grab just the website address, place it into read CSV, because notice that bank list is still a .csv file, and you'll be able to grab it as well. So before we move on, I did promise you guys to show you guys about how to maybe scrape a little bit of maybe, let's say, Wikipedia data. And you know what? Let's go to Wikipedia here, and let's see something that we know has some interesting information. I don't know, I'm going to grab Pokemon, okay, just for fun. And let's see here if they have, okay, so notice here, first one here, this is definitely a table, right? There's another table here. There's another table here. There's tables here, here, here. There's tons of tables, okay? Actually, I know for a fact the reason I picked this one because I know it has some tables. But we could also do, let's do something maybe a little bit more businessy. Okay, so let's say, well, again, maybe let's look at failed banks. That's what we looked at with our FDIC data. And notice here, there is data here for failed banks as well. So let's use this one. So I'm going to grab the Wikipedia address, and we're going to go and call this wiki failed banks. And we know it's going to be a list, so I'm going to call it a list. And so we do pd.read not CSV, HTML, there we go. And we send in the link here. So now if we look at our wiki failed banks list, notice here there are several. Well, there's actually let's actually look at how long this is. Okay, so let's look at the length. And if it's only one, then this isn't very interesting to us, but we'll go about this anyways. So let's do wiki banks, and so we want to grab the first one. So wiki failed banks, we want the first one. So wiki banks, and we run this, and now we have successfully, and you know, let me do the head so we see a little bit clearer. We have successfully scraped some data from Wikipedia. Okay, it has all of that information that we had there. Notice it's actually smart enough to drop out some of the information that was embedded inside of there. It got rid of the little flags for each of the countries and all of that information as well. So let me go back and I would like to show you guys that other example. Because again, we'll grab the Pokemon one because it has a ton of examples of tables. So let's call this poke list. Run this, and then if we look at the poke list here, notice this is a little bit more messy, and it's because there are a lot of lists. So let me go back up here and let's actually look at the length of this particular list. And we see here 45. There are 45 tables in that one Wikipedia page. So then it would take, this is going to where you would have to spend a little bit of time investigating and seeing which list you actually want. So let's look at the first one here and notice that this is again, I don't know what any of this is. I'm just looking at what they had. Okay, so let's maybe just grab the fifth one. And notice this actually has all kinds of information. So it would just depend on your own preference how you want to grab this data, but it's certainly easier than going and trying to copy something in by hand or go in and type everything out yourself. So just know that we have this ability to use pandas in this way. So let's maybe go and see here about maybe doing some operations with this data. Okay, so let's practice our data selection skills. I'm going to use the I like our banks data set, so I'm going to use the banks data set, and we'll just even use that small subset. So let's talk about utilizing some operations. So now again, there are a ton of operations that we actually have with pandas. So if for example we want to say let's say banks.head, and let's just take another look at it, and actually, you know what, grab banks.info maybe. Yeah, okay, so this is per state. Now let's say that we want to see how many unique states that we have here. Okay, so again, we see here Kansas, Florida, etc. So let's do banks, and then we want state, and then dot unique, and this will give us specifically unique observations. So here we would have, it actually gives us back a NumPy array of all of the unique number of attributes. Okay, so unique items in this list. So let's also double check here. For example, I'm curious how many there are. So if we look at the length of this, we see that there are 44, there are 50 states. So again, that means that there is probably some missing, at least again, this is a subset of the list. Now that's nice and all. Now I use this length method in here, but there is actually a better way to do this. So if we did the banks, and instead of unique, we actually just put an in here for in unique. And notice it still does the same thing. Okay, in unique is for the number of unique items. So number of unique observations. Now we can also do a very useful thing as well. We want to maybe count in this data set how many times each of these states appeared. So we can do value counts. And we run this and notice now we actually have a fantastic looking list here where we have the number of counts for each of the states. So this counts each of the unique observations. Now, this is great to just see it like this, but, okay, this is just a little preview of stuff. We haven't really gotten into plotting and visualization or anything yet, but this, look how cool this is. Dot plot. Okay, now notice this doesn't look very good, so maybe let's change this to kind is bar. And notice what we have. We have a nice plot, okay, of our counts, okay, where it has each of the states. Now again, this is a little small, so I'll do a little bit of. Oh, actually, I don't even have that imported, so I'm not going to worry about it right now. But we were able to do plots just right off of our statistics. Okay, so that is a fantastic way that we can do this. Now, let's maybe look at reviewing some of the selection stuff that we have talked about as well. So let's say that we want to grab banks, and I don't know why I'm not remembering any of the columns at the moment. So let's do banks, and we want to say we want bank certifications, okay, and we want to say where they're less than, let's say 2,000. Let me see. What numbers do they have in here? So these are 15,000, 16,000. So I wonder if there's any less than, let's just say any less than 2,000 for now. Okay. Whoops. Banks. Okay, so that narrows it down, right? Now, let's say that we also want it to be and where the bank state is, let's say, equal to Arkansas. Now, there's going to be a problem, okay? Notice, and again, bank, but there's still going to be another problem here whenever I run this. Now, notice here, it's going to have this type error here. Now, the reason for that is that when we're doing these expressions like this inside, we need to cover them with parentheses, okay? And so now we run this, and this works fine. Notice that there is only one observation where there's the cert is less than 2,000, and that is in Arkansas, and that gives us this exact match here, okay? So we can also do this, maybe let's change this up to, I don't know, let's say Illinois, for example. And notice now there are 2 banks that actually come up in this instance. So this is a great way for you to be able to select data and grab all of that data that we have. I'm going to go through a couple other things that are maybe a little bit more complex than what we've done before, but I think that they'll be interesting. We haven't really covered how to do functions a whole lot, okay? So, but I'm still going to go about that just really quickly. So let's say that we want to apply a function to some of our data. So we are going to define, and let's just say div by 1000, okay? And so we're creating a function, and we're going to have it return x divided by 1000, okay? Now we want to actually create our banks. We're going to take the cert data, and then we want to use apply and use a, well, we can do this in a couple different ways, but right now, let me just apply it like this. And so div 1000. And notice what this did is this divided out all of the certs by 1000. Okay, so you can apply a function to anything here. So if you see here this cert, for example, okay, was, let's actually look at the head of cert. And you see here, so this first 5, and let me actually do .head here. So we just look at the first 5 together. Notice here, you can see that each of these values here were divided out by 1000. Okay, so we're applying this mathematical function, applying it, okay, to that column. Now we can do this in another way. We can apply, for example, a lambda function. Okay, so if we do banks, and again, I'm going to do just the cert because it is the only numerical value that we have, dot apply. Now, if we want to do this in a one-line code, we can do lambda x such that x divided by 1000. We run this, and again, it's going to give us our same answer that we had before. It's just another way to do it. Now, we can also use NumPy functions. We can use sum functions, and let's actually go on and do that really quickly. So let's do banks dot sum. Whoops, and I don't want that sum. I want it on cert. And we run this, and we see now it just adds up that entire column. Okay, so there are a lot of different selection criteria, applying functions we can do, and we can also go about actually cleaning up some of the data. Okay, so for example, let's say let's go about maybe with grabbing the bank data. I want to make something a little bit different. So we have a closing date here. Okay, so let's make a copy of some of the data and do something a little bit weird. So do banks new day, or no, I'm just going to call this new column. And we're going to just make this a copy of the banks, and let's call this closing date. So this is how we were actually making a copy. We're just creating a new series object in here. And so now if we look at banks.head, notice now we have a new copy, okay, of that data. Now we can enact on this in any way, shape, or form that we want, but let's say that you just want to maybe, I made this just so that I can remove it, okay? I want to actually delete this row because I don't actually need it. I accidentally made this copy. I was supposed to maybe apply some function to it. Maybe I was supposed to edit this so that it's a cleaner type of date time format. Then all I have to do is use the del or delete. And so here we have bank, and let's do banks. And I call that new column. Now this, I'm putting this in here. This will delete perm, all right, permanently. Okay, it's going to remove that column. So if we do banks.head again, and you look, notice it deleted it, okay? So this, just be wary, that deletes it permanently, okay? And that is, again, going to be very useful for us when the time comes. So that's how we would deal with that column. Now, we can also double check the index. Whoop, and again, banks. Banks. I don't know why I named it banks. I should have just named it bank. I'm too lazy to write it all out. Now, one more thing that we can actually do. Let's do maybe two more. Okay. So first, let's actually sort this. So right now, notice here that none of these are in any type of order. They're just kind of in the way that they were put in. My guess is we would really maybe want to see them in, I don't know, maybe by the closing day. But let's say that we want to clean up this data set a little bit and just kind of, we're not going to group them right now, but we're just going to sort them by the state. We can grab the banks data and then do sort values. And then we want this by, and here we can say state. And this will put this in, again, alphabetical order. If you want to, we can descend them as well. So this would be ascending as false. And this will flip it around so then they're in reverse alphabetical order. Just the same way, so this one we were sorting everything by state, which is alphabetical. Let's do this for the cert as well, so that we can show what happens with numerical data. So banks dot sort values, by, and we're going to say cert, and we run this. Notice here, this is going to be in ascending order. So then you want it in descending order, comma, descending, ascending is false. And this will put this in descending order. Now this is very, very useful. So if we go back and let's go back to our example where we did this plot. Okay, I'm going to copy that. And I put this here, and I'm going to go and just do the value counts really quickly. And let me say here dot columns. Notice there's no columns in here. Okay, it doesn't really have any names. So I'm going to actually turn this into a data frame real quick. And you can see here that it's going to give us an index of state. So we should be able to do something like dot plot. And let's see what it looks like. Oops, and plot still needs to have a bar, or kind as bar. Here, and notice that this is, again, we have this nice descending order. We are also able to then do something like dot sort values, okay, and then let's say ascending is false. Whoops, and I didn't do a by in there, whoops. And I think that was state is what it was keeping it as. So by, and I'm going to actually say, I believe it's actually 0. Nope, I don't remember what it is. Let me see here real quick. Let me remove this. This is what happens when you do stuff on the fly. But again, this is something that you guys can actually look at here. So it doesn't actually have a name, so I don't know if this is going to work at the moment. But I'm going to try it one more time here. And say, let me see, state. Okay, so state, it's still going to do this, but then if I want it to be descending, that should change it. Yeah, there it is. Okay, so we wanted to keep this by our descending order. And again, what it is that this doesn't make a lot of sense that the descending values are by state, but that's just what our data frame called our count values, because it's count value by state. So then you can change the look of your graphics later on by changing up and just sorting the values. And it's very, very useful depending on the story that you want to tell with the data. Now, one last thing that we can look at is this banks.isNull here. And it doesn't actually, this doesn't mean a whole lot right now, but it's just telling us if there's a missing value in there. And then we can also do something like sum here. And notice this actually gives us and tells us how many missing values there are. So that's the last thing that I'll cover in this section. All right, and as always, guys, thank you very much for tuning in. If you guys like this, please comment and subscribe down at the bottom, and let us know what you think. Thanks. Bye-bye.